Okay, 4.7c, the law of cosines. This is the last section here of semester 1. Woo, we made it. All right, so let's cruise. Law of cosines. So we know about law of sines. Now there's a law of cosines as well. So again, this is a little bit of review from geometry because we talked about this back in when we did that. All right, so we noticed that there are law of sines we can use all the time. There are times where we can't use the law of sines. For instance, when you're given the measure of all three sides, like side, side, side. And with law of sines, you need at least one of the angles. So if you don't have any angles and you have side, 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 you can use the law of cosines. Or maybe if you have two sides and they're included angle, side, angle, side, that would be another instance in which you could use the law of cosines. Okay, so here's the law of cosines. You've got a triangle. A, B, and C are the angles. Sides are opposite those. Lowercase a, b, and c, like we've been dealing with. And here are your law of cosines, okay? A squared equals b squared plus c squared. We've seen that before, very similar to Pythagorean theorem, but we add a little bit of a piece to it with the cosine. So a squared equals b squared plus c squared, and then minus 2bc times the cosine of a, angle A. Okay, you can also write it in terms of B, and you could also write it in terms of C as they have right here. Now, just to point out again, though, just keep in mind that if you're talking about side A, then you're using the angle. You're taking the cosine of that angle that's opposite, angle A. Same thing with B is here, and then big B, the angle B is what you're taking the cosine of. Same thing with C over here. And then the other two sides are kind of in the middle. Right here, you can see the B and C, and the B and C are here. So these are always in the middle right here. Okay, so that's the law of sines. We'll try to kind of apply that to what we're doing. All right, find the perimeter of triangle ABC if they give us the angle A is 102 degrees, angle C, or sorry, side C is 84, and side B is 78. Okay, so we can already see right here that we don't have side A, so that's what we're going to have to try and find, but we do have angle A. So that's what we're going to try to find here. So I'm going to write the law of cosines in terms of A. So A squared equals B squared plus C squared minus 2 times B times C times the cosine of angle A. And now I'm just going to put in those things that we're trying to find. I don't know what A squared is, so I'm going to keep it that. But B I have right here is 78 squared plus 84 squared minus 2 times 78 times 84 times the cosine of angle A, which is right here, cosine of 102. All right. Now, you can do all of this whole piece right here in your calculator straightforward. Most calculators will do it right away. Okay? So, when you plug that in, you'll get A squared. I believe it comes out to like 15,000 and some change, 15,864 and 4748, whatever. You can round it if you need to, but that's A squared. So now I'll take the square root of both sides, and that's the noise it makes when you take square root. I don't know if you knew that or not, but that's what happens. And then so A comes out to be about 125.95, or I guess you could go 126, whatever. I'm going to keep it at 0.95 because it didn't say in the problem to round to the nearest tenth. Usually we round to the nearest tenth, which would round that up to 126. Okay, so but remember they wanted the perimeter. So that means we're going to have to add up all those sides. So the perimeter is going to be A plus B plus C. So if I take 125.95 plus 84 plus 78, that'll give me the perimeter. And so our perimeter is going to be like 287.95. Or I guess if you round it, it'd be 288 units. That's units. Okay. All right. So that's what the little application where they're trying to find the perimeter. We had to use it. All right. So let's do a little story problem here. A group of friends are out camping. They're trying to go on a hike. And according to the map shown, what's the angle that's formed by the two trails that lead to the camp? So here is one trail that leads to the camp. Here's the other trail. So we're kind of interested in this angle. What is that angle that the trails have? Okay. We don't know what it is, but we do have all three sides you can see here. So we can use law of cosines to solve for an angle. So this is the angle I want to find. So I'm going to start with the side that's opposite that one and write it in terms of this. So 1.5 squared equals the other two sides, 1 squared plus 2 squared, minus 2 times 1 times 2, because those are the other two sides, times the cosine of, we're going to call it angle A because we don't know what it is, right? That's the one we're trying to find. So we're going to use it and try to find a angle. So again, we're going to do the same thing. However, remember, we're going to have to inverse cosine at the end because we're trying to find an angle. All right, so let's go ahead and square some of these things. This is where it's harder to just do this straight through in your calculator because of the inverse. So you might have to do it in pieces here if you're trying to find an angle. If you're trying to find a side, it's really nice. You can just punch it in the calculator. But when you're trying to find an angle, you do have to do some work here. So 1.5 squared is 2.25. We know that's 1. We know this is 4 when you square those. And then 2 times 1 times 2 is going to be 4. So I've kind of got a minus 4 here times the cosine of angle A. All right. These two together are going to make 5. So it's really 5 minus 4 times the cosine A. Now, the big mistake people make is they try to do this and make it 1. That's not true. You can't do that. Don't do that. No. No. Okay? Don't do that. So instead, because they're separate, because that 4 is attached to the cosine of A. So I kind of got to do it like a two-step algebra problem. So think of it like a two-step algebra problem. I'm going to subtract 5 from both sides. And now I've got negative 2.75. Those canceled equals negative 4 cosine of A. Then I'm going to divide by negative 4 because this is multiplication here, right? So I divide by negative 4. And I'm going to get a weird decimal here. Crazy decimal. Now here's where you can kind of do these two pieces at the same time. I could divide this and then just end up taking the inverse cosine and doing that, or I can actually kind of calculate it out. I get 0.6875. You'll notice you get a crazy decimal because of cosine of A. So again, you could do this here, or you could wait and do it right here, but I got to do the inverse cosine, and I would get angle A equals about 46.6 degrees. Okay, so when I divide here, I can get the inverse cosine. All right, moving on. Oh, solve the triangle. So these ones are the ones that take a while. But you don't have to use law of cosines every time. Once you have enough information, maybe it's faster to use law of sines. Okay, so in this case, solve triangle A, B, C. So we need everything. They give us side A, side B, and side C. So we need all three angles. That's basically what we need. We need angle A, angle B, and angle C. Okay, so if I start with law of cosines, because I don't have any angles, so I got to use law of cosines, I can find one of the angles. So if I start with A squared equals B squared plus C squared minus 2BC times the cosine of A, I can at least work on finding angle A. So let's plug that in. I'm going to go 19 squared equals 24.3 squared plus 21.8 squared minus 2 times those side lengths times the cosine of angle A, which we don't know. All right. So calculated it out. This comes out to 361. I combined these two right here. I squared them and added them. And so I think I get 1065.73. And then this part here, I multiplied all those together, and you got 1059.48 cosine of A. And now it's that two-step problem we were talking about. So first, I'm going to subtract here. from both sides. So I end up with a negative 704.73 equals negative that whole thing. Okay, and then when I divide, I'm going to end up with the cosine of A, and this is where you're going to get a weird decimal, 0.665, and it keeps going and going. Okay, well, that's where we're going to do our inverse. We inverse that, then we'll get angle A, and angle A is going to come out to be about 48.3 degrees. Okay, so I have angle A, 48.3 degrees. But that's all I have right now. So let's continue working. But now, here's where on the second part, I'm going to draw a line right here. And draw a line right here in my box. Second part here, I can use law of sines now because I have one of the angles. Because I have this 48.3. So I can go sine of 48.3 over A, which is 19, equals, let's use it to find B. So sine of B over my B value of 24.3. And then when I cross multiply, I'm going to get 19 sine of B equals 24.3 times the sine of 48.3. And when I divide that by 19, you'll see using law of sines, angle B is going to be like 72.7 degrees. All right, and now I can find angle C by just using the 180 property, taking 180 and subtracting the other two angles. And you'll end up getting angle C equal to 59 degrees. And so I have all three angles here. All three sides were given, so I have solved the triangle. Those are the ones that usually take the longest time, as you know from law of sines. All right, one last thing. Heron's formula. All right, so this is another way to find area when you have all three sides given to you. Okay, so when we know that all three sides, and we have the little side thing, right? It's all three sides. So that's side, side, side. What the heck? Side, side, side. Then I can use this formula here. Okay, if we have all those measures, then we can use this area formula, the big giant square root of S times S minus A, S minus B, S minus C. But we need to calculate what S is as well, where S is equal to 1/2 of all the sides added up. Okay, so let's practice that one on here now. Okay, so find the area of this triangle, ABC. All right, well, I know my area formula is simply formula is big radical and then S times S minus A times S minus B times S minus C. But I need all those values. I need S. What is S? So S is going to be equal to 1/2 of all of these, A plus B plus C, right? It says right here. So if I just 1/2 of all the sides added up. So 1/2 of 44 plus 47 plus 53. So adding those up, that comes out to 144, and half of 144 is 72. So S equals 72. Now I can use that to plug in here in this formula here. So I've got 72 here. So S minus A is going to be 72 minus side A, which is 47. And then 72 minus side B, which is the 53. And then 72 minus side C, which is 44. And so this will work out nicely for us. Multiplying, again, just do the subtraction first, right? Order of operations, do the parentheses first. So it really comes out to 72. And then we have 25 here, 19, and 28. So we multiply all four of those numbers, and you end up getting a large number that we're going to take the square root of, 957,600. Square root of that, we get the area equals 978.6 feet squared of our area. All right. So that's it for law of cosines. Woo, another 15-minute video. We are rocking. See you on the flip side.